So in this video, I'm going to talk about going from fractions to decimal form and from decimal to fraction form. Doing a little bit of review of some stuff you probably had a long time ago, and then introducing you to some new stuff you probably haven't seen before. So let's first talk about the basics of going from fraction form to decimal form. You can see right here I have written this out. This is the fraction 2/5. And we can turn that into a decimal just by doing 2 divided by 5, which is just doing the top divided by the bottom, right? So let me just show you on the calculator. If I want to get the decimal for 2/5, it's just 2 divided by 5. Boom, 0.4. Now, if I want to do something like 2/3, you'll notice when I do 2/3 that I get a decimal that goes on and on forever, right? So on your calculator, you do 2 divided by 3, and you get this repeat, 66666 on forever. There are lots of fractions that end up repeating. For instance, so that was 2/3. I could do 1 divided by 9 for 1/9, and I get 1, 1, 1, 1, 1, 1. And I could do, let's see, 1 divided by 7 for 1/7, and I get a really kind of long repeat, 142,857, 142,857. So the decimals and fractions definitely get kind of interesting with a lot of different repeats, and we're going to talk about how we can turn a repeating decimal back into a fraction. So let's start with some easy decimal to fraction ones that are easy to get. So any decimal that ends is easy to write as a fraction using the correct power of 10. So for instance, 0.3, we read that as 3/10. It says its name. So we write it as 3/10. It ends in the tenths place. Now if we have a decimal like 0.25, that ends in the hundredths place, so we write it over 100. And you can check that on your calculator. You can check that if I do 25 divided by 100, I do indeed get 0.25. Also, if I do 1 divided by 4, the simplified version, I get 0.25 as well. Now, what if instead of 0.25, I wrote 0.251? Well, for 0.251, it now doesn't end in the hundredths place anymore, right? Now it ends one place more, so I add one more zero, and it's 251 over 1,000. So that's how you do decimals that end. It's a little more difficult to write a decimal that doesn't end, like our 0.666666 that we had before, because if it doesn't end, what do I put it over? Do I put it over 10? 100? Do I put it over 1,000? There's no choice there of what to put it over. So I'm going to show you a special way to rewrite this so that we can write it as a fraction. So what I'm going to do is I'm going to let x equal this repeating decimal that we have. If I multiply by 10, I have 10x on this side, so I'm going to multiply each side of this by 10. If you multiply a decimal by 10, it moves the decimal place over 1. So if I have on my calculator 0.6666 times 10, then it moves it over 1. If I have 0.12 times 10, moves the decimal place over 1, right? So that's the idea here, is we're moving the decimal over 1 place. And then what we're going to do is something kind of strange. We're going to take this 10x, we're going to take the x that we have over here, and we're going to subtract them. So I'm going to put the x right underneath and a minus sign here. And I'm going to subtract them. And why would I do that? Well, what happens when you subtract these guys? Let's line them up perfectly. See all those sixes? We're going to subtract all of these sixes, and what happens is they all cancel out, and we get 6 minus 0 on this side. So what's 6 minus 0? 6 minus 0 is 6, right? And what's 10x minus x? So here we have 10x, and here we have minus x. X is the same as 1x. So what's 10x minus 1x? It's 9x. So now we have 9x equals, and again, what's 6 minus 0? 6. So we have 9x equals 6. Now what do you do? To solve for x, to get x alone, divide both sides by 9. So you want the 9, which is multiplying the x, off the x, right? So you're going to divide both sides by 9. When you divide by 9 both sides, you get the 9's off of this side, so you just get plain old x, right? But over here, you get, well, what is 6 divided by 9? We don't want to do the decimal form for that. So, because we're looking to try to get a fraction, right? So we're going to say, okay, that means if I divide by 9, I get x is 6 over 9. That's a fraction. Now, I can write the 6 over 9 as 6 over 9 like this, which reduces to 2/3 or simplifies to 2/3. And that's our fraction. You can always check it on your calculator and see. Sure enough, 2 divided by 3 is, there it is. Look at the little 7 on the end. That's my calculator rounding the last digit off. That is not real. It does keep going as 6's. All right, let's try another example. Now, any kind of repeat works here. So what I'm going to do is I'm going to change this repeat to 1 6 1 6 1 6 1 6, right? Slightly different kind of repeat, right? If I multiply by 10, we move the decimal over one place, so it looks like this. Whoops. Well, we really don't want it moved over one place. Like that's one place moved over. We want to move it over 2 places. And I'll show you why in a second. So let's not multiply it by 10. Let's multiply it by 100. If we multiply it by 100, like this, then this is what we have, right? We have that number right there. Why would I do that? Because the repeat is 2 digits long, right? 1 6 1 6. I want to move over 2 places because then the underneath number is 1 6 1 6. Look at how they line up again. Let me make it line up a little prettier here. There we go. Whoops. There we go, right? Now, I'll move this guy over a little bit. Now they're lined up right under each other for the subtraction, right? And now, what's 100 minus 1x? 99x. What's, all those 1 6's cancel out, and what do I get? I get 16. And what do I want to divide? Not by 9 anymore, but by 99. Right? And so now I have 16 over 99. And that cannot be reduced. It's just 16 over 99 for my new one. So what happened here? We had a 2-digit repeat, so we multiplied by a number with 2 zeros by 100, which has 2 zeros to move it over 2 places to cancel all of those. So now let's try one with a 3-digit repeat. And I'm going to erase all this in case me typing on top was kind of confusing, and we'll do it brand new, fresh. But I want you to think about this for a second. I'm just going to stick in another number here and make it into a 3-digit repeat. 216, 216, 216, 216, 216. So I want you to pause the video for a second and think about what you would multiply by to move the decimal over so that when you subtract, everything cancels. So if we multiply by 1,000, that's going to move the decimal over 3 places. So now we have 1,000x, and we have this long number. And I just realized the one that had 100, I still had the 1 place. It's not great that I typed right on top of that. Should have said 2 places. So now we have 999x, right, is equal to, and what do you get when you subtract there? You get 216. And so what's your fraction going to look like now? Think about it for a second. So now your fraction is going to be 216 divided by 999. Now you can check if you can reduce this fraction or simplify this fraction by using your divisibility rules. If you look, 2 plus 1 plus 6 adds up to 9, so this top number is divisible by 9. And you know 999 is divisible by 9, right? So you can use your calculator and you can do 216 divided by 9, and I get 24. So it's going to be 24 on top. And on the bottom, if I divide 999 by 9, I get 111. Now I can look at that fraction, 24 over 111. And I can see, all right, maybe I could reduce this some more too. Keep on using your divisibility rules. Now, the top one is divisible by 2, but the bottom one is not divisible by 2, right? Because it doesn't end in an even number on the bottom. But if I add 4 plus 2, I get 6, which means the top number is divisible by 3. And if I add 1 and 1 and 1, I get 3. So the bottom number, the denominator, is divisible by 3. So stop for a second and see if you can divide both of those by 3 to get your final answer. So I like to kind of make little notes as I go along what I'm dividing by. So I just wrote down here that I divided by 3, and I'm going to divide by 3 again and just note it here so that I remember. Now 24 divided by 3 is 8. For 111, I'm going to use the calculator, 111 divided by 3, and I get 37, which is prime. So that's nice. It means that we can stop there. And so my final answer for this is 8 over 37. And it's just worth checking that that works. 8 divided by 37, and I get 0.216. There we go. So that's how you turn a repeating decimal into a fraction. Remember that if you have a decimal that ends, all you do is put it over the power of 10. So if I just had 0.216, I wouldn't need to go through all this mess if it's not repeating. Then I would just do the fraction 216 over, do you remember? What would you put 216 over if it didn't repeat? You wouldn't do 216 over 999, right? Think about it for a second. You would do 216 over 1,000. There you go. So just remember that if it ends, it's over the same number of zeros as you have places. If it repeats, you want to go through this little algebra to turn it into a fraction.